actually. I was just going to do that. Okay. So mass by volume concentrations is what we're going to look at today. And really, they're not very specific, which you guys probably may or may not have heard one time before. The important things with mass by volume concentration, now we're caught up. Percent, okay? Percent is grams out of 100, so we need to make sure we remember that. And it's measured in milliliters, grams out of 100 milliliters. Parts per thousand, PPT, is grams out of 1,000 milliliters. So if you kind of think about that, PPT, grams out of 1,000, right? ppm, grams per million milliliters, is what you need to know there. And there's other units, you can switch them if you want, but those, remember those, and that'll give you a good basis to start from, okay? So make sure, absolutely, you have to know these three, okay? Those are the three we focus on. And yes, there's other ones. There's parts per billion, there's parts per trillion, and so on, but we're only going to worry about these three for us, okay? Like I said, you might hear these in the news or on the Weather Channel or whatever the case might be, and they would have maybe perhaps some different units though, okay? All right, so what does it mean if we said, hey, I have a solution of salt water and it has a mass by volume concentration at 12%? Well, that's telling you that 12%, 12 grams out of 100 milliliters of water. So it's 12 grams in this case of salt in 100 milliliters of water. That's what it means, 12%. Percent means grams out of 100, so 12 grams out of 100 milliliters. If you put 12 grams of salt into 100 milliliters of water, you'd have that concentration, 12%. Okay, that's what it means. This here you don't have to worry about. We always just assume that it's 1 gram per milliliter, so you don't need to worry about that. That's nothing. Okay, let's just move on here. So, well, it's not nothing, but it's going to be the same anyway. Doesn't matter. Sam measures out 3.85 grams of sugar and puts it into 750 milliliters of water. So here we go. 3.85 grams of sugar. And he puts it into 750 milliliters. They want to know, what's the percent concentration for this solution? All you are doing in this particular case is making equivalent fractions. Okay? Equivalent fractions. So if I wanted to figure out, gee, you know, I have 3.85 grams in 750, and then somebody else wants to make the same solution, the same concentrated solution, how much would you need to make in 100 milliliters? How much would you have to use to make these two equal? Percent means grams out of 100 milliliters, right? That's what percent means, grams out of 100. So how many grams should I put into 100 to make it equivalent to 3.85? And once again, there's lots of ways you can do this, okay? This goes back to Unit 2, right? But there's lots of ways you can do this. You can say this is 7.5 times less, so that's got to be 7.5 times less. It's equivalent fractions, guys. Cross multiply and solve if you want, whatever you wish to do. Yep. 0.513, and that goes on forever, okay, grams. And once again, it's up to you how you wish to do this. If you want to cross multiply and solve, by all means, go right ahead, right? So that times that and that times that, right? 750 times x, 3.85 times 100. Solve for x, 0.513 repeating, okay? Up to you, don't matter, however you wish to solve that. But now, here's the thing. We still need to use significant digits in this unit, of course, so this is kind of our first introduction into some mathy stuff in Unit 3 here. We still need to use significant digits. In our question, we have 3 and 3, so we probably should have 3 here. So your final answer here, remember the 0 in the front does not count, don't forget, okay? So 0.513 is your significant digits there, okay? So that is recorded as 3 significant digits. You may also see this as an option for an answer, though, especially with multiple choice. Okay? It says calculate the percent concentration. Remember, when you solved this, it was 0.513 grams in 100 milliliters, right? So 0.513 grams out of 100 is the same as saying 0.513%. So that might be another option as far as an answer goes. Because what does percent mean? It means grams in 100, and that's what they asked you to find here. Okay? So either one of those answers would be acceptable in this case, and you may see either or on the multiple choice part for a test. Okay? So just know that if you see a bunch of answers that say percent and you're not sure, well, that's what they're doing there. Okay? Common mistakes when you see this is people want to change it from a percentage to a decimal. So they see percent and they think, oh, I need to put 0.00513 or something like that. That's not what we're doing. Okay? Percent specifically means this. So this part right here means that you'd have grams out of 100 milliliters, right? If you get 40%, okay, yes, it's 40 out of 100. That's what we're doing here. 0.513 grams out of 100, okay? We're not asking you to change it to a decimal or anything like that. That's not what we're doing. If you do change it to a decimal, technically you'd have grams out of a milliliter, and we don't want that, okay? That's not what we're trying to do here. We're trying to get percent, grams out of 100 milliliters, okay? So if you get 0.513 grams, and that's out of 100, it's also 0.513%, okay? We'll look at a few more here, don't worry. This one here, we got 3.20 grams of sodium chloride is put into 15 liters of water. So 3.20 grams, and we're going to put that into 15 liters of water. Okay. What is this concentration in ppt? Once again, you have to know the three. If you don't know what the three things stand for, okay, there's really no point in doing these questions because I'm telling you right now, you'll get this on the Unit 2 test, and these are easy marks, I think, and you're going to get them on the final too, okay? And by the time the final rolls around, obviously we've done a lot of stuff, but these are easy, 2% marks kind of thing, right? So let's not forget that when the time rolls around. PPT implies grams out of 1,000 milliliters. That's PPT. That's from the first, I don't know where you guys are, but that's on my first slide. Okay? Yep. Oh, absolutely. Yeah. So then you look at these two, of course, and you say, okay, that's fine. This is pretty straightforward, but which one of these obviously don't match up, right? We need to make sure we're comparing apples and apples and oranges and things like that. So we have grams and grams is fine, but we have liters and milliliters. So you need to convert one. I don't care which one you convert. You can convert this to 15,000 milliliters, or you can change this to a liter. It's up to you. I like to change this to a liter, but it totally does not matter. You will get the same answer, obviously. Okay? Remember, parts per thousand means grams per 1,000 milliliters, or grams per liter. Same thing, right? So cross multiply and solve here. Once again, however you wish to do it, that's a 15th as much, right? Divide by 15, divide by 15, yes? Cross multiply and solve if you want. Whatever. 15 times x, carried away there, equals 3.2 times 1. Okay? So 3.2 divided by 15, of course, for your answer. And I believe you get 0.2213, repeating grams. Okay, 2.13, or 0.213333, et cetera, et cetera. Okay? Once again, significant digits, of course, so 3 and 3. Let's make sure we have 3 in our answer here. So we'll say 0.213 grams would be my final answer there. And once again, is there another way we could represent this? So is there a way of saying, sure, it's 2.213 grams. What's it out of? It's out of 1,000 milliliters, right? Look right here. Your answer here was 0.213 grams in 1,000 milliliters. Well, grams per 1,000 milliliters or grams per liter is the same as saying PPT, yes? So that might be another option there as well for you. 0.213 PPT, grams per 1,000 milliliters. Okay? Good. Any questions so far? We just got a couple more examples here and then let you guys do your thing. Questions, anyone? Okay. All right. This one here. You got a solution of potassium nitrate and the concentration happens to be 1.86%. So 1.86%. That's what 1.86% means. It means you would take 1.86 grams of solid and you'd put it into 100 milliliters. Okay? What mass of potassium nitrate would you find or have to use in 750 milliliters? Okay? So once again, it's just simple equivalent fractions, right? Cross multiply and solve, or 100 to 750 is a factor of 7.5, so I have to take 7.5 times 1.86, right? Cross multiply, whatever. You're going to get 13.95 grams here, all said and done. Okay? Once again, like I said, it's up to you how you wish to do that. If you want to cross multiply 100 times x, 1.86 times 750. And then, of course, divide both sides by 100, right? And you'll get 13.95. Significant digits. First of all, 3 and 3 in the question, so we should probably round it to 3 here too. To round this one to 3, we're going to have to go to 14.0 grams. Okay? First things first. Secondly, is there something else I could use to represent this? So I have, in this case here, I have 14.0 grams in 750 milliliters. Do we have a special abbreviation for that? Is it, is there a percent or PPT or ppm that I could use to represent 14 grams in 750? Do we have a special one for 750? No, right? So this is probably all the question would ask you in this case. The question would be, of course, what mass would you expect to have for these two concentrations to equal out? And it'd be, of course, 14 grams. All right? 14.0 grams. So there's no PPT or ppm with this because it's not out of one of those special units. It's not percent because it's not grams out of 100. That was this one here, actually. This one's out of 750. So grams out of, next one is grams out of 1,000 milliliters. That's PPT, and grams out of 1,000,000, that's ppm. That's none of those. So that's our answer. All right? Let's look at the last one here. What volume of 2.15 grams in 100 milliliters of magnesium chloride would you need to measure out to contain 25 grams of dissolved solute? So the other thing you could have said here is 2.15%, yes? Because that's what grams out of 100 means. Same thing, yes? So 2.15 grams out of 100. If you had 25 grams of solid, basically they're asking you what volume would you have to use in order to match up those concentrations, right? So if, for example, one of us used 2.15 grams in 100 and said, okay, it turns out I don't want to use 2.15 grams, I got 25 grams that I can use. How much water do I need to go with that to make the exact same concentration? And the answer, of course, is, well, probably do some cross multiplication here. 2.15 times V, 100 times 25. And we get for an answer here, 62.790 milliliters. Okay? Once again, the units have to match up, right? We got to apples, apples, Ferraris, Ferraris, right? Porsche, Porsche, right? Which is not really a, yeah. All right. So, no, it's not. Don't lie. Okay. No. So, significant digits, right? 3. We got 3. We need to have 3 in the answer. Well, that's going to be a little tricky. We need to probably use some scientific notation. So 1.16 times 10 to the 3 milliliters would be an option for this answer. Once again, it could be a numerical response question. It could be multiple choice. I guess it depends. Okay. So that's one option, using 3 significant digits. Okay. The other one would be to say that 1.16 liters. converting milliliters to liters, of course, factor of 1,000. So that might be another option there. Okay, and usually, you know, if it's numerical response or whatever, they'd say how many milliliters or how many liters would you have. So they'll give you that abbreviation or that unit to use there. So either one of those would be acceptable answers there. Okay, for this particular one here. Alrighty, so that's mass by volume. Okay, and that's what you're going to work on. I got only about 3 questions for you today for that. So it won't be very much there for that.